So if I have x to the n, what's its antiderivative? And a very standard practice, I think I've done this at least once before, very standard practice is called the antiderivative of something big, what I call big ass f. What is the antiderivative of that? What has to happen? So what happens with the derivative? I multiply by the power, right? And then I make the power go what? So if I take the derivative of x to the 7th, how does that work? What's the derivative of x to the 7th? Yeah, 7, I multiply by the 7, and I make the power go down by 1. So I'm going to do the exact opposite, which desperately makes sense, because anti-differentiation is the opposite of differentiation. So I'm going to make the power increase by 1, and divide instead of multiply by that new power. And what's missing still? Yeah, that stupid plus c that's going to... It's not stupid. It needs to be there. But I'm going to echo what's going to be in your head as you get problems back. What I normally do on a test, if you miss enough plus c's, I kind of take a point off for every 3 plus c's you missed or something like that. It's important. Now, coming back to this. This piece has to be pretty straightforward. It's that question of changing gears. So, because now you're going to do the opposite of differentiation, so you got to think backwards. So with sine and cosine, it gets a little trippy about negatives and so forth, right? Okay, so shifting gears between differentiation, and then you got to go backwards, and you're like, "Grr." So I understand grinding the gears of math. This guy, though, what's the rule? So if I go one step back, I don't need big ass f because I can just go down a derivative. Do you guys see that? So that would be this guy's antiderivative. What's the rule for this? I make the power up 1, and then I divide by that new power. It's the exact opposite of the way differentiation works, which desperately makes too much sense because we're doing the opposite of differentiation now. So what's the power going to be now? 3 over 2. And then I divide by that new power, but when it's fractional, how do you divide fractions? Multiply with your simple, so I'm going to put a 2/3. I'm not done yet, but let's check what we got so far. How can I check? It's a really good idea each step to check. Because the minute one of these is off, everything else is crap after that. So if I took this guy's derivative, what happens? 3/2 comes down, times 2/3 is 1. And the power goes down by 1. Beautiful. Hey, we're good. We're right so far. What about this one? I want you to start to realize constant multipliers do not mean shit with any of this, right? They come for the ride. So I don't care about the 2. I do kind of care about the negative, though, because that's one aspect about sine and cosine. Cosine would come from cosine's derivative is negative sine. This is what I mean by changing gears. Do you guys not understand now what I mean? Cosine's derivative is negative sine. Where would cosine have come from? Whose derivative would cosine have come from? Sine. I like it. So this becomes 2 sine, and there's still a negative because it didn't involve changing the sign. Okay. That might have been what you meant, but yeah. Okay, sorry. And what's still missing? All right, let me stop for a second. You can always, anytime you take the antiderivative, which is a little new to us, it's just doing the opposite, but it's kind of, you got to think backwards. Beautifully, you can always just check yourself. Take the derivative. just to make sure you're in the right place so far. Now I got to do it again. I'll go one more step here. So here's how I do this part. 2/3 comes for the ride. This is still semi-new to us, but I want you guys to realize constant multipliers really don't do shit. They just come for the ride. What happens to t to the 3/2? It's t to the what now? In general, when I'm anti-differentiating, the power is going to go up by 1 instead of down. So 3/2 up by 1 is 5/2. Shortcut works here too. I don't know if you guys remember, the shortcut for differentiating was 3 minus 2 is 1/2, right? 1/2. 3 plus 2 is 5/2. It works the other way too. It's beautiful. If you don't know what the hell I just said, then you have to be able to add 1 to a fraction. What goes in front here? What goes right here? 2/5. You can either think of that as the rule or realize it just makes sense. I don't want shit here after I take the derivative because I don't want to mess that 2/3 up. So that 5/2 would come down. If I put its reciprocal there, it kills it. So sure, it's the rule. Sure, it's the exact opposite of what, but it also just makes sense in that way. And then I can put that shit together in a minute. Where's negative sign come from? What's the antiderivative of a constant with respect to t? Oh shit. Where would c have come from? CT? I like it. And then of course now here you can't put plus c again because then you're assuming a lot. I have no idea if the constants would be the same, so guess what I use? D. All right. And E and F and G and H and I until we go insane. So and then you got one more step, and I'll let you guys do that next step for yourself on homework. Is that cool? All right. So the more you know your derivatives, the easier this will be, but this will always be a little wonky at first, and actually forever, unfortunately, because it's always that idea of, am I taking an integral, am I taking an antiderivative right now, or am I taking a derivative right now? And you got to really keep yourself going the right direction. Okay, I like it. Yes?
So, like for an example of this on the test, would you want the final answer? Would you want us to combine like the fractions, or can we?
Oh, yeah. I mean, here would be 4/15.
Okay.
Yeah, you keep going. Yeah.
Okay.
I like it. Any basic simplification you have to do. You're right. I like it. I'm excited. There's a question from homework. Are there more questions from homework? Okay. The feeling that means not everybody's done section 4.8 yet. Because if you have, there would be questions, because it gets a little bit interesting. Okay, so before we get into 5, I do want to focus on this idea of antiderivative. Let's do a couple more examples, and then I'll give you this sheet to work on. So everybody got what they want from this year? More than you wanted? I know. So let's see if you guys remember the idea behind this. So find big ass g of x. Let's see if you guys... So when you see this, for me, that means find the antiderivative. So that capital letter is sort of meaning the antiderivative, just same way as f prime meant the derivative of f. It's just another symbol we use. We don't make it even bigger for the next antiderivative up. This only works for one level of Antiderivative. So what if I had this here? Let's see. What do you got, Jeff? 1 over x plus 7. What would big ass G be? So again, now you'll start, if you start to really think about these and do these, you'll realize it is this whole thing about thinking backwards. Where would that have come from? What would I take a derivative of to get here? Yes. Yeah, and what's the, anybody remember the little thing to be careful about? How to do absolute value. And of course, plus C. Yeah, that thing is going to drive you a little bit batty. If any of you have to take a course called differential equations someday, that plus C stuff becomes even more important because you're going to have like several constants and you have to set them equal to each other, figure out what they're. But for right now, it's still freaking important. You're not right if you don't put it. You guys remember about the absolute value? Is that all right? Because it's not fair. This guy can handle -8, but this guy couldn't. So we have to put absolute value to make it match up. And really, what does 1 over x look like? What does 1 over x look like? Sweet. What does 1 over x look like? Okay, draw it on your paper. Draw it. If you have no idea, draw like a little happy face or something. I'll still think you're doing it because you'll be doing something. Just 1 over x. What's it look like? That looks more like a logarithm, I think, what you're doing there. I don't know, maybe. It's got sort of that. It's this, right? So now think about it. I want you to really. So if this is what did I call it? If this is g of x, then big ass g of x is the function whose derivative is this. Is that cool? That's the whole idea about big ass g, antiderivatives. So there is slope down here. So g of x cannot be a function that does not exist here. That wouldn't make any sense because there is slope there. I like it. So it's not just matching the domain. It really is, but it's even more fundamental than that. There's an answer to slope here. There better be a freaking function here. So what does this look like? Let's say the c is 0, okay? Just so I don't freak out about the c when I try to graph this. What does natural log of absolute value of x look like? What does that absolute value do? Think about it. Think about it. What would that do to the picture of something? So if x is bigger than 0, what's the absolute value do? What's an absolute value do to a number that's already bigger than 0? What's it do? Does it do anything? No, it doesn't. I like it. So it's going to look like natural log. So here's g of x. It's going to look like normal old natural log on this side. All right? On this side, it's going to be the reflection of that. Because if x is less than 0, I get natural log of -x. And people see that, they sometimes freak out. They're like, you can't put a negative inside. I'm not. If x is negative, then -x is positive. And I don't know if you guys remember about transformations from pre-calc, but -x inside makes it reflect around the y-axis. So then you get this. And let's see if this makes sense. This is supposed to be the derivative of the green line. A negative getting more negative. Negative getting more negative. Positive going to 0. Big positive going to 0. It matches. It makes sense. I love it. Okay, that's enough of that. I say this, my teacher never made a big deal out of this, and I made a lot of mistakes later because they didn't. So I try to make a big deal out of, this is the official answer to this. The absolute value has to be there, or you will make mistakes later. Okay, I like it. I like it. All right, so let me do a problem that's got a little twist on this. Whoa, hello. All right, fine. let's do big ass h of x. Why not? So h of x, get out of there, equals, you can do it, Jeff. 1 over 2x plus 3. This is a beautiful example about making a smart start and then adjusting it. So what the hell do I mean? This is something that really is useful for these antiderivatives. I know the answer has to look like what, but I'm going to be a little bit off. The answer has to look like what? Based on what we just did. What's the answer going to be? We're not going to be quite right, but we don't care because we're not going to be done when I write down my first kind of guess. What's it got to be? Natural log of? Kick ass. Now why am I wrong? All right, not just because I'm missing plus c. I don't care about that part right now. Because when I take this guy's derivative, what do you get? What do you get? What's the derivative of ln of anything? It's 1 over that thing times the derivative of the inside. What's the derivative of the inside? So look underneath. So if you take this guy's derivative, don't you get 1 over 2x plus 3? Chain rule says times the derivative of the inside. Is that what this is? What's the extra shit I want to get rid of? A multiple of 2. So what am I going to put out here to kill it? 1/2. I mean, that's almost too nice to believe. Do I want that 2? No, I don't. It's not there. I'm wrong if what I write down comes up with a 2 there, because it's not supposed to be a 2 there. So what do I need in front to kill that 2? A 1/2. Constants are beautiful. You got a extra constant? Kill it. No problem. You got an extra x, you're screwed. Can't do shit about that. But constants, I can play with it. They can go in and out. I can factor them out, put them back in. That's why they're so nice, constants. So maybe. Let's try one more like that, and then I'll unleash you on this. Maybe green is not a good option, Jeff. Keep going for green. Are you the good blue? Maybe. Ooh. Let's see. Somebody left a marker in here, you never know. Oh, yeah. All right. So what if I have f of x equals, what do you got, Jeff? I don't know, Jeff. Cosine of 4x. What's big ass f of x? See how the inside is linear, which means any chain rule piece is just going to be a constant multiplier. I don't know if you guys are all with me on that. If the inside wasn't linear, I'd be a little screwed. Actually, I would be very screwed. Where's cosine come from? Sine. So the same idea, it's just the multiple I'm off by, right? Let me put that down so we don't freak out. Why can't that be the right answer? Because if I took this guy's derivative, what would show up outside? What's the derivative of sine 4x? Times 4. So what do I put out here to kill it? 1/4. I like it. I mean, that's almost too nice to believe. Now, just to show you, let me make sure. Because if I show too many of these that work, you start to think that it works on anything no matter what, but it's not going to work on this problem. Let's see, what have I not used? It's used k. Cosine of x squared. And again, I know this is new, but you need to start to realize, there's nothing that'll save this. We are currently not able to do this, and it's very possible this is impossible to do. I like that. It's very possible this is impossible. Now think about it. Try to start. No, a capital K, Jeff, is not easy. All right. if you try to start to do this, I hope you realize where things go wrong. Cosine would have come from sine. If you take this guy's derivative, what's missing? Is it just a constant that's missing? What's the derivative of sine x squared? Cosine x squared times 2x. We are screwed. I can't just do this. I cannot. I really want you to understand why I can't do this. The minute I introduce another variable piece, I have changed the rule. Now if I check this, it's even worse. Do you guys see that? Because what rule would I have to use here? At least product rule, if not quotient, depending on how you write it. Do you guys start to see what I'm saying? And no, it's not because of this stupid thing, right? There's just no way to save this guy because he's off by more than a constant. If I try to check this, that's going to be disgusting. Is it going to equal this? Hell no. If you do product rule, don't you get several parts? It's not going to equal this. So you can't do that with this. You can only do it when you're off by a constant, because constants I can factor in, put in, I can do all that. X's I can't. They're the whole thing that I'm looking at. Hopeful. Maybe. Okay, let's try this. So most of these are decently straightforward. There's really only two that are like this. Three, okay. So do the side that's got nothing interesting. The other side's got a lot of pictures and stuff. Don't look at that yet. Or you can't control you, but don't worry about it yet.